One more challenge we had with the gingerbread house was clearing out the material inside the front yard, basically behind the fence and under the overhang of the roof. There's a really unique area of material we have to get out. Now, we could have done this with some 3-axis orientations where we kind of come from multiple planes and try to remove that material, but in this case, it actually worked out for us to try again to use that same convert 3 to 5 strategy. So what we did here was we used a ball end mill with an OptiRough toolpath coming from the very top and converted that motion to 5-axis. So let's take a look at how that worked. So basically we have here an OptiRough toolpath that you can already see is not going to work well. If we open up the parameters, we can see that this was selected in a very specific way, so none of the overhangs were selected as drive surfaces. By doing this, Mastercam does not know that we are currently in an undercut here. So this is going to allow Mastercam to create an OptiRough toolpath that is essentially going to gouge away much of the roof. But being a ball end mill, we don't really mind if this tool starts to tilt a little bit in order to make these cuts safe. So as this OptiRough runs, if this were to become a 5-axis toolpath, we'd maintain the exact same content point as that tool tilts away. We're just going to clear the holder a little bit more, but still have that same spherical point touching material. So in this case, our OptiRough toolpath is a very good base. We actually did this in 2 depths, so this is the first of 2 depths. And also the way we worked this was we did this first with a 6mm ball and then went down to a 4 and then down to a 2 with stock models in between. So as you can imagine, this file got really big with the stock models and convert to 5 roughing toolpaths. That is definitely the case, but they all followed the same exact sort of method here. So again, we're going to go convert to 5-axis, select our tool, select our toolpath that we want to change to 5-axis. In this case, we want Mastercam to create some new links because we don't want these vertical links that pass through the roof of the part. So we want to build some new links based off of our tilt motion. Tool axis control here, we're going to say initial orientation with additional tilt. And one strategy we employed here was turning on limits. Something that we kind of were up against here was this toolpath is a vertical toolpath. So we're at basically B0. And what happens at B0 is that C-axis wants to really swing around. So a tiny little movement of tilt could cause a full 180-degree move in the C-axis. So if we apply a 0.5 degree minimum tilt value here, the tool will never go vertical. It's always going to have a 0.5 degree of tilt. So it will look vertical, but it will never have that case where the C-axis wants to swing around so much. And then after that, we can apply a maximum tilt value, let's say of 70 degrees. That way we're not tilting too far. The next thing we're going to do is tell Mastercam what faces we want to avoid. In this case, we want to tilt basically using everything. We want to refer to all aspects of this tool. And as far as avoidance geometry, we basically want to select everything above the snow on the ground. So in this case, we want to leave some material here. We don't want to go right to 0. So we're going to leave 0.05 millimeters. And in this case, I want to add 1 millimeter extra for the holder. And we'll let the shank and the shoulder of the tool get right up to that 0.05 value. The final step here is applying a linking strategy because, again, the links before were vertical links that we're going to retract up through the roof of the part. So here what I want to do is turn this from a plane into a cylinder. Let's say a radius of 125. And let's click Generate. So our toolpath is generated, and you can see right off the bat, obviously the links are very different, but these are now safe links that are going to get the tool away from the part. We have a stock model here that was used to generate the rest roughing motion of our OptiRough toolpath. So let's use that in Verify and see what this convert to 5-axis toolpath looks like. So we'll select our stock model as our reference material. We can turn on a fixture, select our convert to 5, and click Verify. So let's turn off some of this extra stuff here and click play in our Verify. So this toolpath looks exactly like what an OptiRough toolpath would look like, except now the tool is being carefully leaned away from any overhanging bodies. As the tool progresses down the part here, we'll be able to save a stock model of the finished result here, and we'll be able to use that stock model to reference for the next smaller size tool as we work down smaller and smaller tools to get into tighter corners. So we can see from Verify that this is going to be safe to run. So when we see this run at the machine, it's going to look very different from any OptiRough you've ever seen because there's going to be a lot of tilting and spinning going on, but the material removal you expect is still going to work the same. So this is a really cool way of roughing material out of a really unique corner of this part.